Suppose that a sample space is 1, 2, 3, 4, 5 till 10, and the outcomes are equally likely. Equally likely, it means that the probability of choosing 1 is the same as the probability of choosing 2. Compute the probability of the event E, a number is divisible by 3. Which of these divisible by 3? 3, 6, and 9. So it's a 3 number out of, so the answer is 3 out of 10. Find the probability of getting 2 tail when 3 fair coins are tossed. You can use another method of solving this one. These are mutually exclusive. The probability of choosing head not the same, it will not intersect with the probability of choosing tail. So in this one, I can use a simple thing. What's the probability of choosing tail for the first trial? 1 out of 2. And in the second one? And in the third one, not to choosing tail, 1 out of 2. So it's going to be 1 out of 8. No. This is in case of 3 consecutive tail. So we are going to go back to the sample space. We did it here. It says how many times choose what, head or tail? At least 2 tails, right? So it will be 2 or at least 2 or 3, right? So 1, 2, 3, 4, and 5. So the answer is 4. This is H. No. So it's 4 out of 8. And 4 out of 8 is equal 1 out of 2, right?
Wait.
Yes?
Let's just find the probability of getting 2 tails, not at least 2 tails. So it's a 3 over 8. So tails.
So let's go back. I said wallahi at least. It's okay, no problem. So it's gonna be 1, 2, and 3. So the answer 3 out of 8. So generally, if it say at least 2, it's gonna be half, but only 2 tails is gonna be 3 out of 8. Now for number 11. Given that probability of A and probability of B, and this is the intersection. We said that yesterday that the probability of intersection is equal. Probability of A plus probability of B minus the probability of the union. And the probability of the union is equal probability of A plus probability of B minus the intersection. So if the intersection at the left, the union is at the right. If the union at the right, at the left, the intersection at the right. I want to find the union. So I'm going to add 0.32 plus 0.51 minus 0.15, which is equal 0.68. For number 12, I'm going to add 0.44 plus 0.5 minus the intersection with 0.77. The answer is 0.17. Now, something called mutually exclusive. Mutually exclusive, it means that there is no intersection between A and B. Probability of A is 0.22, probability of B is 0.25. And the union, in case of mutually exclusive, it means that A intersect B is equal to what? To 0. So the union in this case is equal probability of A plus probability of, which is equal 0.22 plus 0.25, which is 0.47. The second one says that A and B are mutually exclusive and the one not find intersection. Directly, it's what? 0, because the mutually exclusive, the intersection is 0. Now, probability of A is 0.66 and the union is 1.07 and the intersection is 0.26. How I can find the probability of B? We should write the rule first. Probability of A union B is equal probability of A plus probability of B minus the probability of the intersection. So what if I wrote the union first and the intersection? It doesn't matter, it's the same. So probability of A union B is 1.07. Probability of A is 0.66. Probability of B, I don't know. This is the one I'm looking for. Minus 0.20. Now, what is 0.66 minus 0.26? 0.4. So 0.4 plus the probability of B is equal 1.07. So 0.4 move to the other side. 0.7 minus 0.4, which is 0.67, equal the probability of B. So the answer is C.